Okay, for today's lesson, what we are going to do is use this interactive tool. And I came to give you some step-by-step instructions attached on the content page. Um, and with that, I wanted to show you the video. I would watch the video first and then read the step-by-step instructions. And then if you need to go back and look at the video, you can do that. Basically, you're going to do some discovery about area. If you look at this interactive tool, it has tangent and derivatives, which that's what we spent a majority of our year talking about. And now we're going to start talking about area. And so in order to play around and discover with what I want you to discover, you're going to need to draw a graph. So that's the first thing you do. You click on draw graph where I just did. And then you pick your zeros or your x-intercepts. So I'm gonna just pick three. So I'm gonna have one at -4, one at -1, let's say one at 7. Okay, so then you pick your x-intercepts or your zeros. And then you click sketch curve. And then you can pull your curve. Maybe I want my function to look like this, or maybe I want my function to look like this. I don't care. You just kind of pull it. And it kind of, if these are your three zeros, it knows what your min and your max would have to be in terms of the first part of calculus and min and max. And then what you're going to do is you're going to click Done Drawing. Okay, from there, you can move the graph, which you may want to do. I like, because that way I can kind of see the top of my graph or wherever I want to go there. I can zoom in, I can zoom out, I can reset my zoom. I can trace, which means I can find this exact point, and it'll kind of tell you that exact point. Okay, so those are things that maybe you'll need. And then the big thing we're going to use here is this area and approximate. Okay, yeah, it'll tell you the actual area, but that's not going to help you answer the questions and figure out what we're going to do in class. So you want to use approximate. So you click approximate. And the thing that you have to do now, and if you read over here, it always kind of tells you what to do. It says select 2 points on the x-axis as the upper and lower limits. So when we do area, unlike derivatives where we found the tangent line for the whole curve, area we have to have upper and lower limits. So let's say I want to find the area from when x is 1 to x is 7. So that means I'm going to find the area under the curve between the x-axis and this. And now that you've done that, it changes and it says specify the number of rectangles. So this is kind of your direction box down here. So let's just try this with one rectangle because that's how we're going to start approximating area. Well, if you move it here, oh, do you see that little red dot it just got right there? That's what I call the midpoint dot. That's not a very good area approximation. It says it's about 47.85. It's not good because you have some outside and you have some that's not done. So let's change it. Let's try two rectangles. Okay, so now I have a red one. And I want to show you this dot here. See, now I have a left-handed dot. So let's look at our left-handed dots here, or left side dot. So there's a left dot, and let me pull this one up until it gets a left dot. There you go. Okay, so that approximate area with those two rectangles is 36.37. Well, what I can do is I can change it. Well, maybe let me try the right-sided dot. So now that one has a right-sided dot, but notice this one, its right-sided dot, oh, it won't have one. Oh, right there. 24, that's even worse. The other dot that you can have, or the other checkpoint that you can have, is right here, the mid one. And let's see if I can find the mid one. Right there, 39 is that approximation. Still not good. Look at all the area that you're not covering. So let's try 5 rectangles. There's the left. There's a left. There's the left. There's the left. It's hard for me to see this on my screen right now. There's the left. That looks pretty good. I could try 6 rectangles. That's 37-ish. Okay. I'm going to try the mid. Actually, let's do the right-sided dot. I'm going to change all these so I get a right-sided one. See if that's any better, if it looks like it covers more. Sometimes they're hard to see. So where that, I keep calling it a dot, but where that mark is where this rectangle would touch the curve on its right side. So there's those, this one doesn't look quite right, does it? There you go. That area is 33. Um, and some of the questions that you're going to have to answer is like, what would happen if I increase this to 10 rectangles? What would happen if I increased it to 25 rectangles? And then, which one gives me a better approximation? The right, where the right side of the rectangle is touching the curve, or the left, where the left side, or the other option that you have is where the middle one, the midpoint of the rectangle touches the curve. And then we will talk in class on how all this works. After you answer your warm-up questions about this, you actually have to do your own little experiment with it to answer your warm-up questions. And then we'll talk about, well, what happens when I have 100 rectangles? Do I have to add them all up? And why did summation, how did summation go with this? By the way, this curve between 1 and 7 of this curve, its actual area was 36. So it will actually tell you the actual area. If I take away my rectangles, you can kind of see that we're going to start talking about the area under a curve. And if you notice when I say under a curve, it's only going back to the x-axis. So that's the area between this curve and the x-axis is what we will be talking about. All right, so read through the directions and then it'll have this website on there to go there and play around and then answer your warm-up questions. And we'll see you in class.